डियर स्टूडेंट्स, अस्सलाम वालेकुम। लेक्चर नंबर 16 लेकर डॉक्टर मोहम्मद तजम्मुल चुगताई हाजिर है। आज के लेक्चर में हम पिछले लेक्चर के तसलसल के तौर पर कुछ मज़ीद सादा और कॉम्प्लिकेटेड एक्सरसाइजेस देखेंगे। उसके अलावा जैसे जैसे हम आगे चलते जाएंगे इसमें एडवांस मैश एनालिसिस से भी एक्सरसाइजेस देखी जाएंगी। आज के लेक्चर में हम आगे चलकर जो टेक्निक्स अब तक हमने अलग अलग से सीखी हैं उनको कंबाइंड करके कुछ मिसालों को हल करना सीखेंगे। इस सिलसिले में सबसे पहली मिसाल जो आपके लिए रखी गई है वो निहायत सादा सी एक मैश की मिसाल है। इसमें एक पॉइंट के अक्रॉस हमें वोल्टेज को मालूम करना है, जबकि एक ही वोल्टेज सोर्स इस सर्किट में कनेक्ट किया गया है। आइए इस सर्किट को स्लाइड पर देखते हैं। सर्किट शोज दैट देयर इज a 6 volt voltage source attached into this circuit along with 3 resistances which are having the values of starting from the left hand side 10 kilo, 20 kilo and 30 kilo ohms. Now we want to calculate the voltage VAC, that is the voltage across the points A and C. To solve this problem, the circuit can be redrawn as shown into the next slide. Now, before we start solving this circuit, we consider that there is an amount of current I1 which is flowing through the circuit. Now, because all the 3 resistances apparently they are in series to each other, therefore we can confidently assume that the same current is flowing through all the resistances. Therefore we can write the KVL equation for this single loop as, starting from the point A, we can write in terms of voltage, that is the product of the resistance and the current using Ohm's law, as 10 kI1. Remember that because the terminal of the 10 kilo ohm resistance which is attached to the point A is also directly attached to the positive terminal of the 6 volt source. Therefore we have put a positive sign next to 10 kI1. We go through the 10 kilo ohm resistance to reach at the point B. At point B we can see that there is a 20 kilo ohm resistance as well, and also we consider that the terminal of the resistance having the value 20 kilo ohm which is next to the point B is positive. Therefore we put plus 20 kI1. In this case also we have considered the current I1 passing through this resistance due to the reason which I have mentioned earlier. After writing 20 kI1, we pass to the point C. At the point C, going back towards the 6 volt source through the bottom branch or bottom wire, we can also see that a 30 kilo ohm resistance is there. Therefore we can write plus 30k into I1 and equate this to 6, because the extreme terminal of the 30 kilo ohm resistance is directly connected to the negative terminal of the 6-volt source. Therefore, simplifying this equation, we can write 60K I1 is equal to 6. Further simplifying it, because we are interested into the value of I1 before we can calculate the voltage VAC, we can write I1 is equal to 6 divided by 60K, and this factor of kilo that will come at the top to become as milli. Therefore, 6 by 60 will be 0.1. Hence, I1 will be equal to 0.1 milliamperes. Now, because from the body of the question we are interested to calculate the voltage between the points A and C, therefore, we can write the equation for voltage VAC as VAC is equal to 10K plus 20K into I1. That will be equal to 30K into, after putting the value of I1, we can write 0.1 milliamperes. That will come up as, after cancelling the milli factor with the kilo factor, we can write VAC is equal to 3 volts. इससे अगली मिसाल में हम देखेंगे कि एक डायरेक्ट लूप लेने के बाद किस तरह से हम उसमें मुख्तलिफ पॉइंट्स पर भी वोल्टेज को कैलकुलेट कर सकते हैं. लिहाजा इस मिसाल में हम दोनों टेक्निक्स को कंबाइन करेंगे, यानी हम पहले करंट अस्यूम करने के बाद करंट की वैल्यू को कैलकुलेट करेंगे, उसके बाद हम मुख्तलिफ पॉइंट्स पर वोल्टेजेस को निकालेंगे. इस तरह से दोनों टेक्निक्स जो कि हमने पिछले लेक्चर्स में पढ़ी हैं कि वोल्टेज को डायरेक्टली कैलकुलेट करना या फिर ओनली करंट को कैलकुलेट करना, इनको कंबाइन कर दिया गया है ताकि आपको दोनों टेक्निक्स को कंबाइन करने की मजीद प्रैक्टिस हो सके. इस सिलसिले में हमने एक एग्जाम्पल को सिलेक्ट किया है जिसमें दोनों टेक्निक्स को कंबाइन किया गया है. आइए स्लाइड पर इस मिसाल को देखते हैं. The slide shows, first of all, there are two independent voltage sources which are involved into this circuit, whereas there exist 3 resistances. We want to calculate the voltage between the points B and D. Now, in earlier examples, what we were doing, we were directly calculating the voltage after devising an imaginary voltage source between the two required points and then calculating the voltage. But remember, in that case, the voltage drops across various resistances were given, whereas in this example, no voltage drop across any resistance has been given, whereas the values of the resistances has been given. लिहाजा अब जबकि हम ऐसी सिचुएशन में आ जाएं जिसमें हमें वोल्टेज ड्रॉप्स मालूम ना हो लेकिन हमने वोल्टेज को कैलकुलेट करना हो, तो हमारे लिए ज़रूरी हो जाता है कि हम उस लूप में से एक इमेजिनरी अननोन करंट को फ्लो होता हुआ कंसिडर कर लें. उसकी मदद से ओम्स लॉ को अप्लाई करते हुए हम मुख्तलिफ पॉइंट्स पर वोल्टेज जो कि रेजिस्टेंस और करंट की प्रोडक्ट के तौर पर होगा को कैलकुलेट करेंगे और फिर फर्दर उसकी प्रोसेसिंग करते हुए रिक्वायर्ड पॉइंट्स के दरमियान वोल्टेज को कैलकुलेट कर पाएंगे. आइए इस मिसाल की फर्दर ट्रीटमेंट देखते हैं. Now, if we apply Kirchhoff's voltage law for the total one loop, then starting from the point A, we can write the point A has been connected directly to the positive terminal of the 6-volt battery. Therefore, we can assume that the terminal of the resistance having value of 10 kilo ohm, which is next to the point A, is positive. Therefore, we can write 10K into I1, as we have already declared that the current I1 is flowing through the mesh. After writing this term, we pass through 10 kilo ohm resistance to reach at the point B. Once we are at the point B, we will be looking towards the point C. And before we reach at the point C, we can see that the point B has been directly connected to the positive terminal of the 9-volt battery. Therefore, we see the positive sign first. Hence, we will put plus 9. After writing the term for the 9-volt source, we can pass through it and reach at the point C. Once we reach at the point C, we will be facing towards the 40K resistance, or we will be facing towards the point D. Therefore, we can write 40K into I1, because we have considered the whole loop is facing the same amount of current passing through it. Therefore, we have written plus 40K I1. Therefore, we pass through the 40K element to reach at the point D. Once we reach at the point D, we will be looking towards the point E, and we encounter another resistance having a value of 10 kilo ohm as well. Therefore, we consider that the terminal of the resistance which is near to the point D is marked as positive. Hence, we can write 10K into I1. After writing this term as well, we pass through the 10 kilo ohm resistance to reach at the point E. Once we reach at the point E, we will be pointing towards the point A. As we are looking towards the point A, we encounter a negative sign, as the point E has been directly attached to the 6-volt battery. Therefore, we will write minus 6, and after that we will pass through the 6-volt source to reach at the point A, which was our starting point. Therefore, we equate all these terms to 0. Now, simplifying it, we can write 60K I1 is equal to minus 3. Further simplifying this expression, we can write I1 is equal to minus 3 divided by 60K, or I1 will be equal to minus 0.05 milliamperes. अजीज तलबा, अब जबकि आपने देखा कि I1 की वैल्यू नेगेटिव आ गई है, तो एक मरतबा फिर मैं वही बात दोहराऊंगा कि नेगेटिव साइन का मतलब ये हुआ कि जो कन्वेंशन हमने सर्किट में शुरू में कंसिडर की है, यानी कि हमने I1 को अस्यूम किया कि वो क्लॉकवाइज सर्किट में से पास हो रहा है, इस नेगेटिव साइन की वजह से we can say that the current I1 is flowing through the circuit in the anti-clockwise direction. फर्दर वोल्टेजेस को कैलकुलेट करने के लिए आइए एक मर्तबा फिर स्लाइड पर चलते हैं। Therefore, using this value of I1, we can calculate the voltage across 40K resistance, which was our initial motto. Hence, applying Ohm's law, we can write V sub 40K is equal to minus 0.05 milli, that is the value of I1, into the value of the resistance itself, which is 40K. Therefore, we end up with minus 2 volts. अब जबकि हमने वोल्टेज की वैल्यू जो कि अक्रॉस 40K रेजिस्टेंस निकालना थी वो निकाल ली है, तो हम इस पोजीशन में आ गए हैं कि किसी भी दो पॉइंट्स के दरमियान हम कोई और वोल्टेज वैल्यू कैलकुलेट कर सकते हैं। यानी कि जो स्टार्ट में सवाल में पूछा गया था कि VBD निकालनी है, उसको हम अब आसानी के साथ निकाल सकते हैं। आइए इसकी प्रोसेसिंग स्लाइड पर देखते हैं। Now, to calculate VBD, we take the path BDCB. That will mean that we will be starting from the point B in the circuit. Now, because we know the value of the voltage at the point C, or the voltage drop across the 40K resistor, therefore, we can consider an imaginative voltage source VBD. Starting from the point B and taking the path B, D, C and back to B, we can write VBD plus, as we reach at the point D, we will be looking towards point C. While looking towards point C, we can see that there exists a resistance having a value of 40K ohm in between the points C and D. And we have just calculated in the previous slide that the voltage drop across this 40 kilo ohm resistance is minus 2 volts. Also, we can see that the terminal of the 40K resistance, which is near to the point D, has been marked as negative. Therefore, we can write VBD minus into the value of the voltage drop across 40K resistance, which is minus 2. So, minus into minus 2, that is why we have written plus 2. After writing this term, we reach at the point C. While at the point C, looking towards the point B, we also see that there is a 9 volt source between the points C and B. Also, the negative terminal of the voltage source is towards the point C, or it is directly connected to the point C. Therefore, we put a negative sign and the value of the voltage source, which is 9, and equate all these terms to 0. Now, simplifying it, we can write VBD is equal to 7 volts. अजीज तलबा, इस मिसाल में हमने देखा कि किस तरह से अगर हमें कोई रेजिस्टेंसेस के अक्रॉस वोल्टेज ड्रॉप्स की वैल्यूज ना दी गई हों, तो हम सबसे पहले उसमें से एक करंट को पास होता हुआ कंसिडर करेंगे। उसकी मदद से हमें जो भी दो पॉइंट्स दिए गए हैं उनके विसिनिटी में किसी एक पॉइंट पर वोल्टेज को कैलकुलेट करेंगे और फिर एक इमेजिनरी वोल्टेज सोर्स को कंसिडर करते हुए एक क्लोज्ड लूप डेवलप करेंगे और फिर उस पर कर्कॉफ्स वोल्टेज लॉ को अप्लाई करते हुए डिजायर्ड वोल्टेज वैल्यू को कैलकुलेट कर लेंगे। अजीज तलबा, अगली मिसाल में हमने एक सादा सा 2 मैशेस का सर्किट कंसिडर किया है। इसमें से दरमियान में से जो कि ब्रांच जा रही है, यानी कि पार्टीशनिंग ब्रांच जिसको हम कह सकते हैं, उसमें से नेट करंट की वैल्यू यानी आई नॉट जो कि इस सर्किट में मेंशन की गई है को कैलकुलेट करना होगा। इस सर्किट को हल करने के लिए भी एक बुनियादी तकनीक हम आजमाएंगे, यानी कि हम एक मरतबा फिर 2 मैशेस में से करंट के फ्लो को जो कि I1 और I2 होगा अस्यूम कर लेंगे और फिर हम दोनों मैशेस की सेपरेट KVL इक्वेशंस लिखेंगे और फिर उनको सॉल्व करते हुए हम I0 की वैल्यू को कैलकुलेट करेंगे। आइए स्लाइड पर इस सर्किट को देखते हैं। स्लाइड शोज a resistive network having 2 meshes, whereas in this network an independent current source has been used. The value for this current source has been given as 120 milliamperes. Now, the values of the resistances in this circuit has been mentioned as well, and we want to calculate the current I0. After assuming the currents which are flowing through both the meshes, that is I1 and I2, we can redraw this circuit as shown in this slide. Now, if we consider the mesh 1, which is dealing with the current of unknown value I1, then we can clearly see that the current through the mesh 1 is directly the exact value of the current source which is attached into this circuit. Therefore, we can easily write as I1 is equal to 120 milliamperes. For the mesh 2, we have to apply the KVL equation. While we apply the KVL equation to the mesh 2, let's start writing the Kirchhoff's voltage law equation from the 8 kilo ohm resistance which is at the top of the mesh 2. And since we have assumed that the current I2 is flowing through the mesh 2, therefore, in terms of product of resistance and current, we can write the voltage expression for the 8 kilo ohm resistance as 8K I2. We pass through the 8 kilo ohm resistance to reach at the edge of the 4 kilo ohm resistance. Therefore, we will write plus 4K into I2. After writing this term, we pass through the 4 kilo ohm resistance which is on to the right hand side of the circuit to reach at the bottom node. Now, because the 4 kilo ohm resistance which is at the boundary of the two meshes, that is shared by both of the meshes, therefore, what does that mean? That in the previous lecture as well, we have mentioned that the two currents will be flowing through this branch in opposite direction. जैसा कि हमने पिछले लेक्चर में एक मिसाल हल करते हुए आपको बताया था कि शेयरिंग ब्रांच में से जब हम करंट्स की डायरेक्शन को देखेंगे तो जो दो करंट्स उस शेयरिंग ब्रांच में से पास कर रहे होंगे, ऑटोमेटिकली उनकी डायरेक्शन एक दूसरे के अगेंस्ट हो जाती है। लिहाजा जब वो इस ब्रांच में से पास कर रहे हैं तो अप टू सम एक्सटेंट दे विल बी कैंसलिंग ईच अदर। इसलिए हम जब एक्सप्रेशन लिख रहे होंगे तो इन दोनों करंट्स के फर्क को सेंट्रल ब्रांच की रेजिस्टेंस से मल्टीप्लाई करेंगे ताकि हमें वोल्टेज ड्रॉप अक्रॉस दिस ब्रांच भी हासिल हो जाए। आइए देखें कि सेंट्रल ब्रांच में से वोल्टेज ड्रॉप को किस तरह से रेजिस्टेंस और करंट की प्रोडक्ट के तौर पर लिखा गया है। Therefore, we can write the next term, which will be for the 4 kilo ohm sharing resistance between the two meshes as plus 4k into I2 minus I1 equals 0. Simplifying this equation, we can write 16k I2 minus 4k I1 is equal to 0. Further simplifying it by putting the value of I1 into this equation, which we have calculated into the previous slide and was 120 milliamperes. Therefore, we can write 16k I2 is equal to 480. Further simplifying it, we can write I2 is equal to 480 divided by 16k is equal to 30 milliamperes. अब जबकि हमने I1 की वैल्यू भी कैलकुलेट कर ली है और I2 की वैल्यू को भी हमने कैलकुलेट कर लिया है, लिहाजा हमारे लिए निहायत आसान है कि हम I0 की वैल्यू को कैलकुलेट कर सकें। वही बात जो अभी थोड़ी देर पहले मैंने आपको बताई कि I1 और I2 क्योंकि अपोजिट डायरेक्शन में सेंट्रल ब्रांच में से फ्लो कर रहे हैं, लिहाजा नेट करंट की वैल्यू को निकालने के लिए हम दोनों वैल्यूज का डिफरेंस लेंगे। इसलिए आइए स्लाइड पर देखते हैं कि किस तरह से इनके डिफरेंस को कैलकुलेट करेंगे। सादा मैथमेटिक्स है, आइए देखिए। So I0 will be, I0 is equal to I1 minus I2. That will be equal to 120 minus 30. Therefore, I0 is equal to 90 milliamperes. अगली मिसाल में हम एक दो मैशेस का सर्किट लेंगे, लेकिन इसमें हमें सेंट्रल ब्रांच में से करंट को और किसी आउटपुट टर्मिनल्स पर वोल्टेज दोनों को कैलकुलेट करना होगा। लिहाजा इस मिसाल में आपको कंबाइंड प्रैक्टिस का एक मर्तबा फिर किसी और एंगल से मौका मिलेगा। आइए स्लाइड पर इस सर्किट को देखते हैं। इन दिस सर्किट there is only one voltage source which have been used and having a value of 12 volts. Now rest are resistance connections, and we want to calculate the current I0 which is flowing through the resistance 6 kilo ohm and the voltage V0 which is across the 4 kilo ohm resistance which is onto the extreme right hand side of the circuit. We can redraw the circuit as, when we redraw the circuit, first of all, the standard practice that we assume the unknown current quantities which are flowing through each of the loops. Therefore, if we declare the left hand side mesh as the mesh 1, hence we can assume that the current I1 is flowing through the mesh 1. Similarly, we have declared the right hand mesh as mesh number 2, and respectively we assume that the current I2 is flowing through the mesh. Now, we will write the loop equations for each of these meshes separately, and then we try to find out these values. First of all, applying KVL to mesh 1, we can write, starting from the top left hand corner, we see that 2 kilo ohm resistance is attached to that, and a current which we have just assumed I1 is flowing through it. Hence, we can write 2K into I1. After writing this term, we move to the next junction and we write plus. We can see that a resistance of 6 kilo ohm is there, therefore we write 6K. And once again, as I have mentioned into the last example, that the current I2 and I1 is flowing through this branch but in opposite direction. Therefore, we must take the difference of the two currents. Hence, we can write 6K into I1 minus I2. After writing this term, we reach at the negative terminal of the 12-volt battery. Therefore, we can equate this to 12. Or alternatively, we could have written it as minus 12 equals 0. It's the same expression. Simplifying this equation, we can write 8K I1 minus 6K I2 is equal to 12. We can also apply Kirchhoff's voltage law at mesh 2. Once again, starting from the top node of the mesh 2, which is before the 8 kilo ohm resistance, we can write 8K, and because we have just assumed that the current I2 is flowing through the mesh 2, therefore we can take the product of 8K with I2. Next, we reach at the junction of 4 kilo ohm resistance. Hence, once again, we can write plus 4K into I2. After writing this, once again, we reach at the sharing resistance, which is the boundary branch between the two meshes. Hence, the same convention as we have used into the mesh 1 while writing this term for the mesh 2 as well. Hence, we will take the difference of the two currents. Therefore, we can write plus 6K into I2 minus I1. And because for the mesh 2, no voltage or current source has been involved, therefore, we are reaching back at our starting point. Hence, we put all these terms equal to 0. Simplifying this expression, we can write 18K I2 minus 6K I1 is equal to 0. अब जबकि हमने कर्कॉफ्स वोल्टेज लॉ को अप्लाई करते हुए दोनों मैशेस की इक्वेशंस को लिख लिया है, तो clearly we can see that we have two equations and two unknown quantities. लिहाजा हम इन दोनों इक्वेशंस को सिमल्टेनियसली हल करते हुए एक क्वांटिटी को कैलकुलेट कर सकते हैं. फिर इस क्वांटिटी को किसी भी एक इक्वेशन में पुट अप करके हम दूसरी क्वांटिटी जो कि I1 या I2 व्हाटएवर होगी उसको भी कैलकुलेट कर सकेंगे. साइमल्टेनियसली हल करने के लिए आइए एक मर्तबा फिर स्लाइड पर चलते हैं. Solving equations of mesh 1 and 2 simultaneously, we can see that 24K I1 in both the equations can cancel out. Therefore, we are left with 54K I2 is equal to 36. Hence, we are left with I2 is equal to 36 divided by 54K. And when we bring this K from the denominator to the numerator, we can write it in terms of milli factor. Therefore, I2 is equal to 0.67 मिली एम्पियर्स। अब जबकि हमने I2 की वैल्यू को कैलकुलेट कर लिया है, लिहाजा हमारे लिए V0 की वैल्यू को कैलकुलेट करना निहायत आसान है। आइए इसकी ट्रीटमेंट को स्लाइड पर देखते हैं। नाउ द इक्वेशन फॉर V0 कैन बी रिटन एज V0 is equal to 4K I2, that will be equal to, after putting the value of I2, 2.66 volts। अजीज तलबा, अगली मिसाल में हम एक 3 लूप का सर्किट लेंगे। देखने को तो ये सर्किट खासा कॉम्प्लिकेटेड नजर आएगा, लेकिन घबराइए नहीं, ये भी पिछले सर्किट्स की तरह बिल्कुल आसानी से हल हो जाएगा। इस सर्किट में 2 इंडिपेंडेंट करंट सोर्सेस जबकि एक इंडिपेंडेंट वोल्टेज सोर्स का इस्तेमाल किया गया है और हमने इसमें पूछे गए मुख्तलिफ मुकामात पर करंट की वैल्यू को कैलकुलेट करना है। आइए इस सर्किट को स्लाइड पर देखते हैं। सर्किट, एज वी हैव जस्ट मेंशन दैट इट कंसिस्ट्स ऑफ 2 independent current sources and 1 independent voltage source. We want to find out the value I0, which is through the 4 kilo ohm resistance. Now, first of all, as our usual practice, we will redraw the circuit by assigning various meshes with appropriate current quantities. Now, once again, I feel easy at starting from the left hand side of the circuit. Therefore, the extreme left hand mesh has been assigned number 1, the middle one as number 2, and the extreme right as number 3. Respectively, we have assigned the various unknown current quantities flowing through these meshes. Hence, we have given I1 for the mesh 1, unknown quantity I2 for the mesh 2, and unknown quantity I3 for the mesh 3. First of all, we look for the mesh 1, and we can see that this mesh involves one independent current source, and that current source is having a value of 2 milliamperes. Therefore, very easily and conveniently, we can write I1 is equal to minus 2 milliamperes. This minus sign has been assigned due to the reason that the current I1, which we assigned to the mesh number 1, has been shown in the opposite direction as compared to the current source. Similarly, the value of the current I3 may also be written directly. आइए इसको भी स्लाइड पर देखते हैं। We can also see that the current I3, which we have just assigned to the mesh number 3, is flowing in the same direction as the direction of the independent current source, having a value of 4 milliamperes. Therefore, conveniently we can write I3 is equal to 4 milliamperes. You can well observe that in this case we haven't put any negative sign next to the 4 milliamperes because both the currents are in the same direction. अब जबकि हमने I1 और I3 की वैल्यूज को सर्किट में बगैर किसी स्ट्रगल के कैलकुलेट या डायरेक्टली ऑब्जर्व करते हुए लिख लिया है, तो हमारे पास सिर्फ एक मैश बाकी रह जाता है जो कि मैश नंबर 2 है। लिहाजा इस मैश पर हम कर्कॉफ्स वोल्टेज लॉ को अप्लाई करेंगे और इसमें से फिर I2 की वैल्यू को कैलकुलेट करने की कोशिश करेंगे। इस मैश में भी आप देख सकते हैं कि हमें रेजिस्टेंसेस की वैल्यूज दी गई हैं, ना कि वोल्टेजेस की। लिहाजा हम कर्कॉफ्स वोल्टेज लॉ भी अप्लाई कर रहे होंगे। इन द सेम टाइम वी विल बी अप्लाइंग ओम्स लॉ एज वेल टू राइट द वोल्टेज इन द फॉर्म ऑफ रेजिस्टेंस एंड करंट प्रोडक्ट। आइए केवीएल इक्वेशन लिखने के लिए स्लाइड पर चलते हैं। Applying Kirchhoff's voltage law for the mesh 2, we can write, starting from the top resistance, which is having a value of 4 kilo ohms, we may write 4ki2. Now this is actually the term first for this loop. As we move from 4 kilo ohm resistance, we reach at the boundary of the 6 kilo ohm resistance. Therefore, we write plus 6k. Be careful, once again, we are at the boundary branch of the two meshes. Therefore, from this boundary branch, two currents will be flowing at a time. However, these two currents will be flowing in the opposite direction as compared to each other. Hence, we will write plus 6k into I2 minus I3. As we write this term, we pass through the 6 kilo ohm resistance to reach at the bottom wire of the loop, that is mesh 2. As we reach on to this wire, we encounter the 12 volt independent voltage source. And to the other end of the 6K, we can see that the negative terminal of the 12 volt battery is directly attached. Therefore, we may well write as minus 12. After writing this term as well, we pass through the 12 volt source to reach at the wire which is between the 12 volt positive terminal and the 2 kilo ohm resistance. Therefore, we can write the voltage across 2 kilo ohm resistance as plus 2k into I2 minus I1. Now, we have reached at the starting point of the loop. Therefore, we can equate all these terms to 0. Simplifying this equation, we can write 12k I2 minus 24 plus 4 equals 12. Now, further simplifying it, we can write I2 is equal to 32 divided by 12k. Or we can further write it as 8 by 3 milliamperes, or that is equal to 2.66 milliamperes. Now, we can also see that the I naught, which is our required current, that will be equal to I2, because that is flowing also through the mesh 2, and the current through the mesh 2 which we have calculated is I2. Therefore, we can write as I naught is equal to 2.66 milliamperes. अजीज तलबा, अगली मिसाल में भी दो इंडिपेंडेंट करंट सोर्सेस और एक इंडिपेंडेंट वोल्टेज सोर्स का इस्तेमाल किया गया है, लेकिन सर्किट की कॉन्फ़िगरेशन पिछली मिसाल से थोड़ी सी डिफरेंट रखी गई है, ताकि आपको ये भी विजुलाइज हो जाए कि मुख्तलिफ सर्किट्स को गो के उनको टैकल करने की टेक्निक एक ही होती है, मगर फिर भी आपको ये विजुलाइज करवाना है कि मुख्तलिफ फॉर्म्स में अगर सर्किट दिए गए हों, फिर भी उनको टैकल करने का बेसिकली वही तरीका होता है जो हम अब तक मैश एनालिसिस में करते आए हैं। आइए इस सर्किट को स्लाइड पर देखते हैं। दिस सर्किट कंसिस्ट ऑफ 2 independent current sources and 1 independent voltage source, whereas only 3 resistances has been involved into this circuit. We want to calculate the current I0 as mentioned into this circuit, that is the current through the 1 kilo ohm resistance. To start with, we can redraw this circuit by assigning various current flow direction into this circuit. Therefore, we define the mesh 1, which is onto the bottom left corner of the circuit, and we assign I1 flowing through it as a current. On the right hand side, onto the bottom right corner, we assign the current flowing through the mesh 2 as I2, and it's flowing also into the clockwise direction. The top big loop have been assigned as the mesh 3, whereas the current I3 has been assumed to be flowing through this mesh. Now, looking into the mesh 1, we can clearly see that the assumed value of the current I1 is opposite to that of the current source. Therefore, we can write I1 is equal to minus 2 milliamperes, as the whole current which will be flowing into this mesh will be supplied by the 2 milliampere current source. Also, looking into the mesh 3, we can see that the current source having a value of 4 milliamperes is the only source of current which is flowing through it. Therefore, we can safely write I3 is equal to 4 milliamperes. Now, we haven't once again accounted for the negative sign because the direction of the two currents are same. Now, we are left with only one current which is unknown to us, and that is I2 flowing through the mesh 2. Therefore, applying Kirchhoff's voltage law onto the mesh 2, we can write, starting from the right corner, which is on top of 2 kilo ohm resistance, we can write 2K into I2 plus 1K into I2 minus I1. Once again, we have written I2 minus I1 because 1 kilo ohm resistance, which is the boundary resistance between the two meshes, or this is the boundary branch between the two meshes. Therefore, the two currents I1 and I2 are flowing in opposite direction as compared to each other. And we also have a 12-volt battery connected into this loop. Therefore, we can equate the two terms to 12. Now, 12, we have put a positive quantity onto the right hand side of the equation because when we are completing the loop, the negative terminal of the battery has been connected at the 1 kilo ohm far terminal, which is next to the 12-volt battery. Therefore, if it was onto the left hand side of the equation, it would have been minus 12. Now, simplifying this equation, we can write 3K I2 plus 2 is equal to 12. Or further simplifying it, we can write I2 is equal to 3.33 milliamperes. Now, in order to find I0, we know that the two currents I1 and I2 are flowing in opposite direction through the boundary branch. Therefore, we can write I0 is equal to I1 minus I2. Putting up the values for I1 and I2 into this equation, we can have I naught is equal to minus 2 minus 3.33. Therefore, I naught is equal to minus 5.33 milliamperes. अजीज तलबा, आज के लेक्चर में हमने कुछ सादा और कुछ थोड़ी कॉम्प्लिकेटेड इंडिपेंडेंट मिसालें देखी, जबकि कुछ मिसालों में हमने सीखा कि किस तरह से दोनों इफेक्ट्स यानी कि वोल्टेज कैलकुलेशन और करंट कैलकुलेशन को कंबाइंड करके एक ही सर्किट में किस तरह से डील किया जाता है। अगले लेक्चर में हम इन्हीं एडवांस मैश एनालिसिस से मुतल्लिक मजीद मिसालों को लेंगे और उनका एनालिसिस करेंगे ताकि आपको ज्यादा से ज्यादा प्रैक्टिस हो सके। इन द मीन टाइम आप घर पर कुछ और किताब में से सर्किट्स लेकर मिसालें ले लीजिएगा और प्रैक्टिस करते रहिएगा। आज के लेक्चर का वक्त खत्म हुआ चाहता है। अगले लेक्चर तक के लिए इजाजत दीजिए। अल्लाह हाफिज।